Hello, my name is John Wendt. I'm a chemical safety specialist at the Environment, Health, and Safety Department here at the university. Asked to come in and spend a few minutes talking to you about the issues that I feel are important in chemical safety, especially for people who may be new to the research lab environment. One of the things I like to say is that the Federal Occupational Safety and Health Administration actually considers, kind of work, even with these small amounts of chemicals that you use in a typical research lab, to be important enough to have actually a special part of, of OSHA law devoted to that. They actually made some comments on this when people were deciding whether OSHA should be involved with chemical safety or not. These are some of the conclusions that they reached in some of their discussions, that some OSHA investigations and some epidemiology, they've revealed that, hey, exposure to toxic agents in a laboratory can have severe consequences, including death. These injuries can occur in any type of laboratory where toxic chemicals are handled. And these injuries would be preventable if people were using the right equipment, had proper techniques, and if they had adequate knowledge, these injuries would not occur. So it really pays to do something, OSHA concludes. So they came up with something called the OSHA Laboratory Standard. Different than a lot of OSHA laws. For one thing, it's fairly simple, and there aren't a lot of specifics to it. They kind of toss the responsibility back to you, or back to the PI in the lab. They consider you the safety experts. These bullet points here are just kind of the complete OSHA laboratory standard spelled out in a few steps. This is what they want you to do. Keep workers' exposures below permissible exposure limits. These, the PELs, these are, kind of published, of course, in safety data and material safety data sheets. These are air concentrations of certain chemicals expressed usually in milligrams per cubic meter of air. And to tell the truth, this is usually easy to do in a laboratory situation. You're using small quantities of chemicals, small surface areas of containers, surface sizes, and it's very rare. The chemical that we do run into is formaldehyde. This chemical has an extremely low permissible exposure limit. It's used in very large quantities when people are using it, and so it can be quite challenging to make sure people are below that permissible exposure limit. Other chemical use, where you can use a fume hood and smaller containers, we usually don't run into that. OSHA wants your lab to have a written chemical hygiene plan. This is a standard, basically what it is, are spelling out those standard operating procedures to keep people safe. Most people just refer to Chapter 4 of our chemical safety guide. Chapter 4 pretty much just states, what are the good standard operating procedures in regard to chemical safety on this campus. OSHA wants to have somebody in charge. If somebody does get injured, where does that responsibility end? It's usually with the principal investigator, perhaps the lab manager. OSHA wants to make sure that people are trained. Hopefully there will be more than, kind of simply looking at this 10-minute talking head of me here on this site for a while. We have formal chemical safety training twice a week at Union South. There's a test, there's a certificate given out to people. That should be, we really encourage people to do that. There should be formal training in your laboratory for the particular hazards in your lab with some documentation of that. OSHA wants you to label all the containers of chemicals. That's pretty basic. They want you to keep the material safety data sheets that come along, that are sent by the manufacturer for chemicals that you're using. They also want you to be able to provide a medical consultation or examination if you feel you have been exposed to a chemical. Again, very easy to do at this institution. Our occupational health department has occupational health physicians on retainer, and if you feel that you need to see one of these people about an exposure, we can easily arrange that. OSHA also wants to know that if you're working with what they call particularly hazardous substances, these are chemicals with a high degree of acute toxicity. They define that as chemicals with low lethal doses, things with the LD50 below 50 milligrams per kilogram. These are the lethal dose, LD50's lethal dose that will kill 50% of a population of mice or rats or the species that they used in the study. So if you're seeing oral lethal doses that are in the 50 kilogram per kilogram dose or lower, that's a particularly hazardous substance. There also is a list of about 180 known listed carcinogens. Again, these are listed in our safety guide. OSHA talks about those. If you're using those by name, it's a particularly hazardous substance. You have to take the steps necessary. There's also a very big category of chemicals that research has shown these to be reproductive toxins. These are harmful to the male or female reproductive system. Of course, the very sensitive system, female in early stages of pregnancy. If you're thinking of becoming pregnant, thinking maybe pregnant, or trying to get pregnant, and you still have to continue working in a chemical lab, please do a serious evaluation or have safety come out and help you do this evaluation of your workplace. The early stages of pregnancy are very sensitive to chemical interference. For no other reason, the simple model, if we get a damaged cell in our bodies, it's one cell out of billions. If a developing fetus gets a damaged cell, it could be one cell out of thousands, and this could have devastating effects for the rest of the development. So be aware of these reproductive toxins. Now, if you're using any of these categories of particularly hazardous substances, OSHA wants you to take a few steps. Establish a designated area, an appropriate designated area. If you're using, for instance, an aqueous solution of acrylamide monomer, this is something that's not volatile. You want to make sure you're wearing the right personal protective equipment and you can clean up areas. But basically, you could possibly have your entire lab be the designated area for that use. If, on the other hand, if you're using something like dimethylmercury, you may want to have just one tiny square foot in the back of a fume hood that be your designated area. Use good judgment on that. They want to make sure they're using proper storage and management, fairly generic terms, but these make sense. They want to know if you're using appropriate engineering controls. For the most part, that would be, are you using a fume hood for volatile chemicals? They want to know if you're using appropriate personal protective equipment. Are you using the right gloves, or if you need a respiratory protection, are you using the right respiratory protection? They want some plan for waste removal, fairly easy to do on this campus. Please consider decontamination procedures. If you spill something, are you using absorbent wipes, or is this an area that's easy to clean up? Also, very important, some planning for emergencies. If you should, for instance, spill this chemical. If you spill it in a fume hood, well, there's usually a lip there. You can wipe this, the material up, usually easy to take care of. How about if you spill it on the floor? Can you just clean it up with some paper towels or some absorbent? Or would you really have to consider evacuating the area? What would happen if you spilled it on yourself? Would it be, could you just kind of wipe the area, go to the locker and change your clothes? Or really, would it be appropriate to make a trip to the emergency room? You should think about these things before you start working with the material. I guess another kind of good safety generality I'd like to give you is, OSHA even talked about this. People who work with, basic chemical use in industry is, people maybe watching cans of paint go by on an assembly line. People in a research lab, they really are smart people. They have degrees, they know what they're working with, and that is truly one of the keys to working safety, is having knowledge and understanding of the materials that you're working with. At the bare minimum, read the chemical hygiene plan for your lab. Look at those material safety data sheets for the hazardous chemicals before you start working with them. Good material safety data sheets have the physical and health hazards, what to do in an emergency, what are these signs and symptoms. Boy, I have a headache. Is that from that acetone I was working with? A good material safety data sheet will give you that information. Read the labels of the materials that you're working with. Know your protocols and procedures and stick to them. Don't get too creative. Good idea for safety, not a bad idea for science, not to get too creative when you're trying to reproduce protocols. Boy, have a good source of safety references. Hopefully there'll be a source of some safety links to safety references attached to this website with this link for this video. Look at the safety department's website. I should say that the chemistry department on this campus, go to the chemistry department website, go to the library section of the chemistry department website. Our librarian at the chemistry department is a very, is a strong safety advocate who has great safety links. And I really should end up by saying that don't hesitate to just call the friendly people at safety. There should be safety, should be some phone numbers and contact information, attached to this page. And I think all my colleagues are in agreement that it is really an enjoyable part of our job, is talking to people on campus for any reason, consultation about a type of research you're doing, consultation about a material, where to get safety references. And we have heard time and time again after an incident, I wish I'd have taken a few minutes to call somebody at the safety department to talk about this before I went ahead and did it. So please, look at those safety references and give us a call whenever you feel it's necessary. Thank you.